Hey guys, welcome to lesson 6.4 on inverse functions. We're going to be spending some time talking about this idea of an inverse function. And so when we talk about an inverse function, one of the things that you have to remember is what we're really looking at when we do an inverse is we're trying to say find a function. Again, two things that are inverses kind of undo each other. And so a function is an inverse function and a function are going to undo each other. They're going to be inverses. So if you think about, for example, if I take x and I add 5, so adding 5 would be 1, and then if I minus 5, that would undo it. And so you would end up getting back to the x that you started with. So if I had x and I multiplied it by 2 and then I divided it by 2, that would give me x again. So multiplying by 2 and dividing by 2 would be inverse operations. Same idea with an inverse function. So we're going to be kind of creating inverse functions as we go throughout this chapter, or for this lesson rather. Now a couple of things here. We talk about an inverse relation and an inverse function. They're essentially the exact same thing. The only difference is in an inverse relation, it says a relation that interchanges the input and output values of the original relation. And so basically we interchange our inputs and outputs, our x and our y's. And we'll be using that idea to create our inverse function. Now, an inverse function has a special meaning, and that is it says the original relation and its inverse relation whenever both relations are both functions. Now, sometimes we take the inverse of something and the inverse is not a function. And again, remember the idea of a function is that every input has exactly one output. Sometimes the inverse is not necessarily a function. So we talk about relations and inverse relations. This always works, but sometimes the inverse is not a function, and so therefore we can, again, we're going to have some differences here. So let's go ahead and try an example here. So I want to fire over here to the one where the answers aren't in it. There we go. And it says find an equation for the inverse of this relation. So in the definition up above when we talked about an inverse relation, essentially what we said is we said, look, to find the inverse of anything, we simply interchange the x and the y. So now we have x equals 7y minus 4. So we're going to add 4 to both sides, and we get x plus 4 is equal to 7y. And when we divide both sides by 7, we get y equals x plus 4 divided by 7, or you can say 1/7 x plus 4/7. Because again, if you split that into 1x over 7, that's 1/7 times x plus 4/7. All right, and so this would be our inverse relation. Now we don't know whether or not that's a function or not yet as of right now, but I can tell you that 1/7 x plus 4/7 is a linear function, so absolutely it is. And again, we'll get into a little bit more about what that means here shortly. Inverse functions. It says functions f and g are inverses of each other provided that f of g of x is equal to x and g of f of x is equal to x. We also write the idea of inverse function with f to the -1. It's read f to the -1, but it's pronounced f inverse. So when we read that, we don't say f to the -1 power. We write it that way, but that means f inverse. When I want to verify that two things are inverses, what I do is I take the function composition of those two functions and make sure that I get back to x. So this is the example that we just did up above up here. We want to verify that our answer, our f inverse of x, is in fact 1/7 x plus 4/7. Well, to do that then, we are going to then simply take the composition of f inverse. Well, f inverse is 1/7 x plus 4/7. So then we're going to take f of that, which says, again, the function f says take 7 times whatever's in the parentheses, which in this case is 1/7 x plus 4/7. And then we're going to take away 4. So again, this says 7 times what x is. Well, in this case, x is 1/7 x plus 4/7. Now we go ahead and distribute. This becomes 1x plus 4 and then minus 4. Those two cancel, and cool, I'm left with x. Now what if I take f inverse of f of x? Well, f inverse, the function f inverse, says take 1/7 and multiply it by what x is. In this case, it's 7x minus 4, and then add 4/7. When I distribute 1/7 to both, I get 1/7 times 7, which is x. 1/7 times -4, which is -4/7. And I still have the plus 4/7 on the outside. Now 4/7 and -4/7 cancel, and I'm left with x. So we can guarantee that those two functions are inverses because when I take the composition both ways, f of f inverse and f inverse of f, we get x both times. All right? So go ahead and try this example here, this checkpoint. We'll be right back with a solution. All right, so to write the inverse of this function, it says y equals negative 3x plus 5. To write the inverse of that, we then interchange the x and the y. So x equals negative 3y plus 5. Now to solve that for y, we would take 5 away from both sides. And I get x minus 5 equals negative 3y. Now this is going to be a little bit tricky here because we're going to divide by negative 3. And I don't want to leave this as x minus 5 over negative 3. I'm going to simplify this a little bit. And so I'm going to split this into 1x over negative 3 and plus negative 5 over negative 3. Because again, when I do that and that, I get these two fractions. Now simplifying, this becomes negative 1/3 x plus, and then negative over negative is positive, so this is 5/3. So y equals negative 1/3 x plus 5/3, but instead of saying y now, what we want to say is we want to say f inverse. Okay, so f inverse of x, again, if this is my function f of x, then f inverse is negative 1/3 x plus 5/3. Now, we need to verify that these are, in fact, going to be inverses. So we have to take f of f inverse of x, and so let's do that first. F of f inverse, well, f inverse is this negative 1/3 x plus 5/3. And then the function f says take negative 3 and times whatever's in the parentheses, which is negative 1/3 x plus 5/3. And then to the end of it, we're going to add 5. So again, this says negative 3x plus 5, but x is my inverse function. When I distribute negative 3, I get positive 1x, because again, 3 times a third is 1. And then this is plus 5. I'm sorry, that's not plus 5, it's minus 5. Because when I distribute negative to positive, I get negative 5. And then plus 5, and conveniently enough, cool, those cancel out. All right? So let's do the other one down here. Let's take a look at f inverse of x. And so f inverse of the function f says negative 3x plus 5. And so we're going to take the inverse of that. So this becomes negative 1/3 times what this is, negative 3x plus 5. And then to the end of that, we have to add 5/3 because the inverse function says it's negative 1/3 times what x is plus 5/3 on the end. So when I distribute here, negative times a negative is positive. 1/3 of 3 is x. When I distribute negative 1/3 to 5, I get negative 5/3. And I still have the plus 5/3 outside. Again, conveniently, those cancel out. And so once again, I'm left with x. So when I take the composition both directions, I get x. And so therefore, those two are inverses of one another. All right, so let's find the inverse of this. Now, I want to kind of avoid this limiting the domain for right now. We're going to kind of ignore this part of it because we really haven't talked much about graphing polynomial functions. Graphing power functions and their inverses. So, first of all, if I want to find the inverse of the function, let's just find the inverse of the function first, and we'll deal with domains at a later time. If I replace the x and the y, I get x equals 4y squared. And then I would divide both sides by 4, so I get x over 4 is equal to y squared. Now from there, I take the square root of both sides. And so remember, whenever you solve a problem involving square root, you always have to consider plus or minus. So y is equal to plus or minus the square root of, now this says x over 4. Well, x over 4 doesn't simplify very well, so I'm going to put it over here for right now and recognize that this is 1/4 times x. So if I was taking the square root of that, it would be the square root of 1/4 times the square root of x. Well, as we know, this is the same thing as the square root of 1 over the square root of 4. And the square root of 1 is 1, the square root of 4 is 2. So all of this told, this simplifies to 1/2 times the square root of x. And so this is plus or minus 1/2 times the square root of x. Now, this is going to be a square root function, and so we're going to kind of avoid all of this stuff. But again, we're not talking about restricting the domain. All I really want to do is I want to find the inverse of that power function. All right? So that brings us to our next idea, and this is the idea of the horizontal line test. Now, the horizontal line test says the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. All right? So the reason that we think about the horizontal line test, we talked about the vertical line test way back in chapter 1. We said some function maybe looks like this, all right? And that function passes the vertical line test because every time that I draw a vertical line through it, it only touches it in one place. And so for that reason, that is a function. Now the inverse of that, basically to get the inverse of a function, what we end up doing is we reflect it across the line y equals x. Since we're interchanging y and x, we're going to reflect it across the line y equals 1x. And so this function that used to be kind of like this is now reflected across this line and turns sideways like this. And so this inverse, and I'll do it in a different color, maybe that'll make a little bit more sense. So if the original function was the parabola that we have drawn there, then the inverse of it's going to be kind of a turn sideways parabola, something like that. Well, because a vertical line can't pass through that sideways parabola without touching it more than once, then the inverse is not a function. So going back to the horizontal line test, what we're going to do is we're going to say, look, because we're going to reflect this across the line y equal x, we can say, look, if I can pass a horizontal line anywhere through this function and it only touches it once, then its inverse is going to be a function. And I'm going to say inverse is a function. Obviously, that's a function. All right? Now, if you're looking at this parabola here, the parabola by itself is a function. So I know that this is a little bit misleading because it says not a function. However, we're not talking about that. Now we're going to say, look, if I pass a horizontal line through this and it touches it in two places, that means that its inverse is not a function. All right? Because I know that the inverse of this thing is going to be a reflection of this graph across the line y equal x. So effectively, it's going to be this graph turned sideways. And since I can't put a vertical line through that without touching it in more than one place, the inverse is not a function. So without doing all of that and reflecting the graph, we can simply pass a horizontal line through the original function and tell whether or not its inverse is a function. All right? So let's go ahead and see if we can't find the inverse of a cubic function. All right? A cubic function, for example, y equals, or f of x equals 1/4 x to the third plus 3. First of all, I want to find the inverse of this function. All right, so the inverse of this function, let's do this over here. And again, I'm going to kind of stay away from all the graphing business for right now. If I want to take a look at this function right here, this is going to be, the inverse of that would be x equals 1/4 y to the third plus 3. And now I'm going to solve for y, so I'm going to take 3 away from both sides. This is x minus 3 is equal to 1/4 y cubed. And now I'd have to multiply both sides by 4 over 1, which becomes 4. This is now 4x minus 12 is equal to y cubed. And now I take the cube root of both sides, and I get y equals the cube root of 4x minus 12. All right? Now, that would be the inverse of that function down here. So that's kind of the work over there. Now they want to talk about making the graph of this thing. Again, let's think about end behavior. Third degree polynomial, positive leading coefficient. It's going to look something like this. All right. And so because I can do that, then I can take a look at the inverse of that. Well, the inverse will be the reflection of that, which would be across the line y equal x. So that would look something like, maybe something like that. All right. And so because of that, again, since the original function passes the horizontal line test, then its inverse is going to pass the vertical line test, and so therefore the inverse is also a function. All right. So again, not too terribly worried about that piece of it in terms of the graphing part. We'll spend more time with that tomorrow. Go ahead and try this checkpoint problem, and let's see how we do. All right, so we simply want the inverse of this function. So this says y equals 2x to the fourth plus 1. If I want to find the inverse, I interchange x and y. X equals 2y to the fourth plus 1. So to solve this for y, we take 1 away from both sides. I get x minus 1 is equal to 2y to the fourth power. We have to isolate that y, so we're going to divide both sides by 2. Now this is getting a little bit messy, but it's y to the fourth power is equal to x minus 1 all divided by 2. So to get the y all by itself, we take the fourth root, and so y is equal to the fourth root of x minus 1 over 2. Now we can't simplify that, unfortunately, so we're kind of stuck, although you could make it the fourth root of 1/2 x minus 1/2 if you wanted to, but I would say this is sufficient here. All right? How about the inverse of this function? Again, this says y equals 1/32 times x to the fifth power. And so if I want to solve that and find the inverse, I interchange the x and the y. And now I'm going to multiply both sides by 32 over 1. And so I get y to the fifth equals 32 times x. So now to get rid of y to the fifth power, I take the fifth root of both sides, because that's the inverse of fifth power. And so I get y equals the fifth root of 32. Well, as you know, the fifth root of 32 is 2. So I can take the fifth root of 32, and then this leaves me the fifth root of x. And so the inverse of the function 1/32 x to the fifth is 2 times the fifth root of x.